This video will look at input, output and storage devices. So we have looked at the CPU, we've looked at different processors, we've looked at how CPUs process data. But a CPU can only process data if it's supplied with data in the first place. And it's the input devices that put data or supply data to the CPU. So an input device supplies the CPU with data, and it is needed so the user can instruct the computer to do something, to get data to the CPU for processing. Now, input devices, there have been a lot, and there are a lot, and they have developed over time. So we've got, a mouse and a keyboard, quite standard, all the way up to touchscreens and motion sensors. But all of these things send data to the CPU, so they're all examples of input devices. Okay, so a mouse, used to move a cursor, select icons on a screen on a graphical user interface, and it's an excellent object for users of desktop computers. It's appropriate for people that are sort of in seated positions. One thing though is that you do need a clean surface to actually use it properly. Okay, a keyboard used to enter text and numbers, different characters into a computer system. It's a reliable form of data entry, but relatively slow to enter text numbers, prone to errors, not good for users with poor dexterity. So a motion sensor, used to capture movement of a user. So users can control a computer system without actually having to have any contact with a device, so that can be really good. But gestures can be misinterpreted by systems. You need light as well. Touchscreen, so users can drag, select, expand screen items without any additional devices. Very intuitive, so no additional devices are required, but doesn't work if fingers are wet or if the user's wearing non-specialist gloves. So that's a disadvantage there. So there's also some specialist input devices, and here's a few examples of those. So OMR, optical mark recognition. So these are devices that recognize marks on a document, which might then correspond to some data that can then be sent to the CPU for processing. So it's often used in surveys, multiple choice exam papers. You've got a barcode scanner as another example of a specialist input device. So scans the widths of the lines and spaces, and they represent unique codes, and those codes can then be processed by the CPU. RFID, so radio frequency identification, similar to barcode scanners, but they don't need to be in the line of sight. So to be able to actually read a RFID code, you don't actually need to be able to see it. So tags are placed on items, and the tags themselves store data in unique code. Unlike a barcode, these tags don't need to be in the line of sight of the scanner, so the scanner sends a signal to the tag and receives a response, which is the code. So there are also input devices for users with specific needs. So you could have an eye tracker. So if a user is potentially paralyzed, for example, paralyzed, they could potentially use an eye tracker to be able to interact with the computer. So camera locates the eyes, the direction of the person's looking in, and the cursor will follow the eye movement. So staring at an icon will select it, for example. Paralyzed users might use a suck puff switch. So they can use their mouth to control a switch. So programs can interpret these inputs to carry out tasks. Users with limited arm movement can use a foot mouse, very similar to a normal mouse that you'd use with a hand, but use it with a foot. Braille keyboard, so users with poor sight can use two types of keyboards: normal keyboard with Braille on it to guide them to the correct letters, or a specialized Braille keyboard where users can select the position of the dots to create each Braille letter. And a joystick as well. So a joystick, users with limited arm movement can use a joystick, another input device to control the cursor on a screen, for example. Okay, outputs. So we've seen that input devices send data into the the computer, so send data to the CPU. An output device is basically what supplies the user with information. So once the CPU has processed data, the information will be sent to an output device to provide information for the user. So mainstream output devices, monitors, visual display units. They display information via pixels. Pixels combine to present with images that we can recognize, we can gain information from. And use them at home, offices, usually accompanied with a desktop computer, but widely used output device there. A projector projects images on a screen or a wall or an object to present us again with images that we can recognize and gain information from. So cinemas, schools, video conferencing, they're the applications. Usually if you want to produce a larger image, a projector's a cost-effective way of doing that. Printers, so you could have inkjet or you could have laser printers, both used to place an image or text onto paper to provide user with information. Can be used at home, can be used in offices. So inkjet printers place wet ink on paper which dries, whereas a laser printer uses static electricity generated by those lasers to attract toner to certain formations, which are then placed on the printer and heated so that they stick. And you got speakers. Speakers vibrate at varying frequencies to produce different sound, so we can hear speech or music, and loads of applications, loads of places where speakers are used. So there are some mainstream output devices. So there might be some output devices that they use more in specialist situations or in industry. So an actuator. So these are output devices which produce movement, produce motion. So they might be used on a plane, for example, to control the flaps of the wing. So if the autopilot senses a drop in altitude, then the computer will send the process data to these output devices, to these actuators, to adjust the flaps accordingly. A plotter. So it's a specialized output device again, which prints huge images onto big sheets of paper or other suitable material. They might be used to create technical drawings or blueprints. Very similar to printers, but they'll often use a pen to create the image as opposed to a printer head. Okay, so there's output devices and certain adaptations to output devices that could be used with users with specific needs. So a braille printer, they work by punching dents into a sheet of paper to form the braille that someone who is visually impaired can feel and interpret its information. Got a voice synthesizer, so these output devices, which is really just a speaker and a screen combined, allows users who cannot naturally communicate to pick letters and words from a screen, and the synthesizer will synthesize human speech to speak the letter or word out loud. Another adaptation or an adaptation to an output device might be a screen magnification software. So it's not really an output device. The screen is the output device, but screen magnification software will adapt the screen so that partially sighted people can more easily read the information on the screen. And a screen reader, again, another adaptation to an output device. So this adapts the output device to the screen to present the text in a spoken form through the speakers. Okay, so we've looked at input and output devices. Now let's turn our attention to storage devices. So primary memory. Memory, as we know, is where binary data is stored, and there are different devices in a modern computer which store data, and in particular, like I said, we'll look at primary memory to begin with. So these are RAM and ROM, and to a degree virtual memory. So when we're talking about primary memory, we're talking about systems memory. We're talking about memory that is directly accessed by the CPU. So the RAM is needed to store programs that are currently in use. So they might reside on the hard drive. When they're not in use, you double click the icon and the program will be loaded onto the RAM. And RAM helps us with multitasking. So it means having several programs open and using at the same time. So it copies the data needed by programs at that time so that it can be passed to the CPU when it needs to process that data. It also stores all the instructions and modules from the open program that the CPU will require for processing. So RAM stores data as small charges of electricity and tiny little transistors. And this charge needs to be refreshed every few milliseconds, otherwise the charge will leak away. And for that reason, RAM is known as a volatile memory device. It loses data when there's no power. If it's going to store data, it needs that constant supply of electricity, that constant charge, so that the transistors can hold the electrical charge and therefore represent a 1, or if it has a less charge, represent a 0. So when programs are opened by the user, they're loaded from the hard drive to the RAM. And this is so the CPU can access the data and instructions at an acceptable rate, because the hard drive is very slow at delivering data. So if the CPU reads the program instructions and data from a hard disk, the data access would be extremely slow. CPU wouldn't be able to work that fast, and that's why RAM is so important. It's much quicker at delivering data to the CPU. Okay, so another primary memory device is the ROM, read-only memory. So if you think about when you switch your computer off, the data and the CPU can access, for example, the stuff in the RAM, loses its data. Okay, so all your data would be wiped if you had only RAM. And that's a problem, because when you restart your computer, you need, data must be in the RAM for the computer to work. But if the RAM is volatile, then how can data reside in the RAM when you switch your computer on for the first time? Well, it can't, and that's where the ROM comes in. So ROM is a special memory chip that can store data even without power. So it's non-volatile, and it's used by a computer to store the boot sequence. So everything that the computer needs to boot up and load the operating system. Those scripts are put onto or stored in the ROM. So when you switch on your computer, data in the ROM is accessed by the CPU in order to start the computer and load the operating system successfully. The data on the ROM cannot easily be overwritten by the user, therefore it's said to be read-only. Unlike the RAM, it is classed as primary storage. It's directly accessed by the CPU, and it has fast data access rates too. Now, virtual memory, it's classed as systems memory, as primary memory. Data is accessed directly by the CPU, but the actual device that virtual memory is on is often secondary storage, which is storage devices that aren't really directly used by the CPU. So yeah, bear that in mind. So RAM is great for multitasking. You can have multiple programs open and use them simultaneously. But if you've got too many programs open in the RAM, then the RAM becomes too filled up. And what would normally happen if there wasn't an alternative sort of solution is, if the RAM's completely full, the computer might stop working. Now, in a modern computer, virtual memory stops this from happening. Now, virtual memory is just secondary storage, so it might be a hard drive, which acts as RAM, although it operates much slower than RAM. So if you're browsing the internet, listening to music, the RAM should cope fine. If you then decide to play a game with good graphics, then it might overload the RAM. Too much data goes into the RAM. And what will happen is that the computer will relocate programs that haven't been used that recently onto the hard disk. So the process will take time, as the hard disk data speed much slower. But when it's done, the system should be nice and fast again. So it swaps data from the RAM out onto the hard drive. So often the operating system will use the hard drive as virtual memory. A lot of programs need to be loaded as part of the operating system, but many can sit on the hard disk as they are used infrequently. Okay, secondary storage. So unlike primary memory, where the CPU directly accesses that kind of memory, secondary storage is slightly different. So in everyday computer use, we need to write data, rewrite data, store data when the computer's switched off, and retrieve data next time we switch it back on. We've looked at primary memory. RAM is great, really quick, but data is lost when it's switched off. It's volatile. ROM is non-volatile, but you can't really write to it. It's read-only. So we need another device, another type of device or devices, which we can rewrite data when we want and store the data when the computer has no power. And that's where secondary storage comes in. Now, there's 3 different technologies at the moment for secondary storage. We've got magnetic storage, technology. We've got optical technology, and we've got solid-state technology. And these are some example storage devices which use those different technologies. Okay, so with magnetic storage. Okay, so these, if you think about a hard drive, for example, it uses a magnetizable material, and it changes the polarity to north and south. So in a hard drive, you've got a platter, you've got tiny little points on this magnetized material, or magnetizable material, and the hard drive reader will be able to read the polarities of these points. So if it reads a point which is positive, so positive magnetization, or north, polar north, then it will represent potentially a 1. It will read a 1. And if the point is has negative magnetization, or south pole, then it will read a 0. So these arrangements of these tiny little magnetized points give us the data. With optical storage, this is where we have lasers which, when we want to write data to the CD or Blu-ray or DVD, it actually burns little pits into the tiny surface, shiny surface, so onto the land. So when reading optical media, another laser, much less strong laser, is shined onto the surface, and if it hits land, then it reflects back perfectly, and it potentially will read, for example, a 0. But if it hits a pit, then it won't reflect back the same way, and therefore it can read a 1. So these different arrangements of land and pits give us our data, and a laser will shine onto the surface, and if it hits land or pits, then it gives us our 0s and 1s, if you like. We've got solid state storage as well, or also known as flash technology. So these work by sending a large electrical current to force electrons through a barrier and trapping them in position. And the word flash technology, flash, is from the idea that you're flashing an electrical current through this device, so that we can actually push these electrons into position and give us our data. And the different arrangement of these electrons gives us our data. So here's our barriers. We've got a flash of electricity, and the electrons are pushed and trapped into a certain arrangement to give us our data. Okay, so if we just very quickly have a look at different types of storage device and look at their uses and benefits, positives, negatives. If we start off with the hard drive, used to store large files, programs and operating systems, large capacities, several terabytes, fairly good read and write speeds, not amazing but fairly good. They're not that portable, they're often quite heavy. Durability is not great. If you drop one, certainly when it's using, that could cause the head to touch the surface of the spinning disk and cause the data to be unreadable. It's fairly reliable though. It does have a limited life, but it's fairly reliable. It can be used over and over again. So magnetic tape used to be used a lot in the sort of 80s for music and certain computer programs. Nowadays it's used sort of to back up data. They can have large capacities, several terabytes, high write speeds but very slow read speeds. And the reason for that is because when you read magnetic tape, you have to read it in series. You have to go all the way through the tape before you get all the data that you want to read. You can't just go to halfway along and hope that the data that you want is there. So you do have to sort of play the tape, if you like, all the way through to actually read it all. It's fairly small, it's light, so it's quite portable, fairly durable. You could drop it and it'll be absolutely fine, and it can be used over and over again, so it's fairly reliable. So with optical storage, you've got CD-ROMs, you've got Blu-rays and DVDs. So these are quite good for media files, documents. A CD in particular has got fairly small capacity, about 650 megabytes. Read and write speeds are moderate, not fantastic. It is incredibly portable, very light, It can take a few knocks, but scratches can cause damage to the data, so it's relatively durable, not fantastic. And reliability, CDRs are write once, but you can read them over and over. CD rewrites can be reused, but there is a limit to how many times they can be reused. Blu-rays much the same, but larger capacities. So we're talking sort of 4.37 gig for a DVD and 25 gig for a Blu-ray. Solid state and flash storage. So we've got solid state drives. Capacities are larger than what you can read here, really, but they are very expensive compared to a hard drive. But they do have really good read and write speeds. They're very quick. If you want to improve the performance of a computer and you don't have enough money to update the CPU, sometimes if you update the CPU, you have to update the motherboard, etc. But a really quick way of speeding up your computer is just to put a solid state drive in replace of the hard drive. They're very portable. They're small, they're lightweight, there's no moving parts, so it can survive knocks and scrapes, and it can be used over and over again, so it's fairly reliable as well. Flash discs, so you've got these little SD cards, for example. They're really good in small portable devices like phones and cameras. No moving part, again, they've got really good capacities, they're super quick read and write speeds, and they can be used over and over again, so they're very good. So it's definitely a superior technology, solid state and flash storage, over the others, but it's still very expensive compared to the others. So flash memory stick, very similar to an SD card. Network attached storage, so a NAS drive. So this is really just a glorified hard drive. So it might be solid state, it might be magnetic, but ultimately it's a hard drive which you can plug into your network, so that no matter what computer you're on, as long as you're on that network, you should be able to access that storage device to write data onto it or read from. Now, in terms of its read and write speeds, it's as quick as a solid state drive or a hard drive. However, what does limit it is the speed of the network. So the transferring data from the computer to the network attached storage can cause slow data access speed. They're fairly heavy, fairly not that portable. Drop-in device could cause damage, especially if it's a magnetic hard disk. But it can be used over and over again. Does have a limited life, but it's fairly good. And cloud storage. So again, this is just a whole load of hard drives that might be stored in a building somewhere in America or in London or across the world. But the idea is that you, no matter what computer you're on, as long as you've got access to the internet, you will be able to access these storage devices and therefore store your data online. So it's used to store documents and media files online. This means that you can go to another computer and access your files, provided that you have internet access. Capacity, well, it's generally unlimited. As long as you can pay for it, there's an unlimited supply. The speed, it completely depends on your network, on your bandwidth. So if you have a poor internet connection, it might take a long time to access your data. Portability, well, it's virtual. You don't have anything to move around. As long as you've got internet connection, then you can access it from anywhere. And in terms of durability and reliability, as long as you keep up your payments and the company looks after their storage devices, it's very durable, very reliable.